Alright, so we're live now, so hello YouTube. Good time to explain this kind of setup. So we're doing a lecture live stream slash video, so hello on YouTube and all of that. How this kind of works, we did this in the past, how this kind of works is I'm gonna do a very brief presentation on Silk.net. And after that, I'm just gonna program here and I'm going to write a very basic program using Silk.net. And I'm probably gonna upload all of that on GitHub at some point before the video goes up. So if you're watching this on YouTube, then you can actually go there and look everything up. Right, so Silk.net. As you can read, right, C# bindings for OpenGL, OpenCL, OpenAL, and also async and ImGui, and a whole bunch of other things as well, actually, like DirectX, I think was in there. Silk.net is very much like OpenTK, but it has a few differences. And actually, I like Silk.net a lot. I like it a lot. Maybe even a little bit more than OpenTK, which is surprising because I built this whole channel on OpenTK. But yeah, Silk.net is a bit newer, I guess. OpenTK has been around for a very long time. Silk.net really hasn't, and I feel like it's right around now that it's really starting to pop off. That's some good stuff. Let's actually get into what it actually is, right? So it is very much for a modern .NET, right? It's kind of new, so it's for .NET 6, Core 2.0 framework, 4.6, etc., for Xamarin and stuff as well. It is made by the .NET Foundation, which makes it kind of official, really. OpenTK is just like a community project. Although this Silk.net is also open source, so I mean, it's not like it's behind closed curtains development. It is still on GitHub, it's open source, you can make pull requests and all of that. So that is still great, but it has some backing, you know? It has some guaranteed great minds behind it. It also has like, some weird support from JetBrains, which is kind of cool. And then of course OpenGL, OpenAL, OpenCL, same as OpenTK, but it also has async and async and ImGui and even SDL bindings, which I don't think OpenTK has. At the very least, ImGui OpenTK does not have, and it's really useful to have. It really is. It really adds a lot, honestly. The reason that I started using Silk.net is exactly because I needed ImGui. And I couldn't find any good bindings in C#. OpenTK didn't provide anything, and then I found ImGui or Silk.net, which had everything that OpenTK has, including ImGui. I'll try to show a bit of ImGui later, actually. And then yes, now it's just coding time. It was really short. There's really nothing to say here other than it just has more bindings, and all of the bindings from OpenTK are still here. They are a bit different, but of course you'll just see that when I start programming. So here we go. So I set up a little program here, just in Rider, so nothing too special. Let's go to the NuGet packages and let's look for Silk. Right, just for Silk, Silk.net.core, seems fine. This just has everything that we need. Yes, we are running .NET 6. This one, so that is totally fine. Let's install just latest version. Good stuff, let's go. Now I'm not sure if we also need GLW, OpenGL and all of that stuff in the NuGet packages. We might. So using Silk.net and it just has core. So we do need all of these extra packages. So it is very modular in that way. This is the whole Silk.net, I think. Yeah, look, this is the whole Silk.net. It includes all of these things. So let's just get that installed to get it over with. But it is very modular, so you can just take only SDL and OpenCL if that's what you need. Okay, now we have everything. So this is the point where I'm gonna get the documentation up on the other window, because I actually don't know everything here. Don't know everything by heart yet. Of course, OpenTK I'm so familiar with. I've made so many little games and things with OpenTK. I know that by heart. Silk.net, I've only done it once, so I need a little bit of help. Hope you can forgive me. So we are going to need inputs. Silk.net has a whole different way of registering and processing your inputs, like from your mouse and keyboard, and all of that. It's actually great. I don't know why OpenTK doesn't do it this way, honestly. Silknet can detect whenever you plug in new devices, so you get like an event trigger whenever you plug in a new keyboard, which is actually great because then you can detect when a new keyboard is there, so you can give like a prompt if you want that in your game. You can at the very least show the player, the user, that they are now able to use their different or their new keyboards. You know, it probably doesn't happen often, but it's still nice to have. So, right, we're going to have to make a window. For that, we can do window.create, and it has some window options, and then it returns, of course, an I window is create, and we have some window options. So let's look at those. Options equals window options.default or default Vulkan. Default is just default OpenGL, I'm pretty sure, right? So options, and then we can look at the API that we're using, and then I'm pretty sure we're always setting that one to default. Yeah, and the default one is OpenGL 3.3 core, which is great. We're not going to touch that. We're going to use the default OpenGL. You could use maybe 4.2 or something, but I mean, 3.3 is fine for us. We probably want to just change the size and the title. That is what most people would want, at the very least. The rest gets very technical. It's usually not necessary. So let's just call this our, I don't know, like Silk tutorial. Wow, great name, how creative. And what I do want to show you is the size one, because you'll notice here that this has a custom vector 2D type, which is a bit different from, of course, the maps that come with OpenTK. You'll notice that this is actually a, what's it called, a generic. Man, I'm using too many templates in C++. It's called a generic in C#. And so you can just make this float or double, whatever. So that is quite nice. 2D vector, of course, has 2 dimensions. So let's make this 1280 by 720, which is always a very nice and small little window, which is useful when debugging. You don't want your debugging screen to take up your whole window. You just want like a little small one so you can see it, but you can also still see the debugging controls up here, which is always quite nice. All right. So we can now create our window with our options, and that's totally fine. Now we have a window. Awesome. So then, just like in OpenTK, some things just never change, you know. We can. Why does it not work? On load? No, it doesn't really. Oh, it's just load. Right, and that is why I have the documentation open. Oh, in OpenTK it's on load, here it's load, but basically this is just an event that gets called every time, or well, the one time that the window actually gets loaded, and OpenGL gets loaded. So this gets called after OpenGL already is loaded, so in the onload function you can, well, load all of your textures and shaders and all of that stuff. You will be absolutely sure that OpenGL is ready and available for you, so you don't have to worry about anything like that. Let's just keep it very, very dirty and just make these inline lambdas. All right, then we can also have an update function plus equals, and then there we go, our update function. I should probably have the parameters in here. There we go. And then the same thing for the render function. Plus equals, probably also double D, and then here is our function. All right. If you're not familiar with lambdas, lambdas are great. Actually, I might as well convert this to a named method. So there we go. It's the same thing. But I'll rename one to a named method just so that it is clear. All right, and then after that, just like an OpenTK, we can just run the window, and that's it. Right, so we just set these callback functions, and then we just run the window. You'll notice that window doesn't actually have stuff for like keyboard callbacks and mouse move callbacks or anything like that. all of these events or callbacks are window based. So we do have a resize one, I'm pretty sure. Yes, and a frame buffer size one, and a render, and update, and a load. So these are all related to the window. The user input callbacks are actually at a different spot. Now, let's see here. Where do we actually get that? Ah, yes. So in onload, so after the window is already loaded and running, we can get the input callbacks. But I do think maybe it's easier to have this in a local, no, not a local function, into a named method. There we go. Let's just change all of these to named methods then. If we're gonna do it that way anyway, let's just be consistent here. Okay. And since I will want to have the window here in onload, I'll have to define window up here as like a private member variable. Private static I window, and we'll just set that like it. I mean, yeah, it's not super clean, but it will be fine, guys. It will complain a little bit because it's nullable, but oh well. You can complain a little while longer. Anyway, what we can do then is we can do window dot create input. And there we go. And then we will get a little I input context that will have everything that we need to handle our input. We should probably have this input context up here as a member variable as well. That is probably a smart thing to do, so we can actually access it everywhere. There we go. So we'll just call input equals window.create input. Mind you that this can only be called after the window is already running, right? So the smart thing about this is that Silk.net first sets up all of the OpenGL stuff, or Vulkan stuff, or DirectX stuff, but let's focus on OpenGL here. Sets up all of the OpenGL stuff. It initializes the window fully with GLFW, and then, and only then, it actually has a functioning window that can receive input. So only then it makes sense to receive input, right? In OpenTK, you can kind of receive input without there being anything to receive input with. It's kind of weird how that works. So this does make a bit more sense. Though I guess if you're not really into all of the C++ backend stuff, like how this actually works behind the scenes, then maybe what I just said doesn't really make any sense, but that's okay. That is totally fine. Okay, so we have the gamepads. Just the handle, never mind that. We have the gamepads, the joysticks, the keyboards, the mice, and other devices. We have a whole bunch of stuff. And we have a connection change. So we can actually detect if a connection changed as it says. So here, let's make this into a lambda then. I don't like that it is not explicitly typed. Oh well. So we can check for whatever our device is, right? So we can have like a switch statement on our device type, or we can even just check it with if statements. So if our device that changed like is a, what is it, like a mouse? Let's see if I'm allowed to do that. I think so. Yes, that is an input device. This is the right one. So if it is a mouse, then what I can do, actually make it mouse. So we initialize it instantly and cast it. So that's great. Like then we can instantly just add new callbacks to it. So then we can say on click, right? Plus equals, and then some function. So what we're doing here, how this works, is we have some connection changed, right? Callback or event. So whenever I plug in a keyboard or a mouse, let's keep it at a mouse for now, this function here will run. Then it will check if the new plugged in device is actually a mouse, and if it is, it will just instantly hook up the click callback to that mouse. So whenever this mouse receives a click event, so whenever I actually click it, this method will run. And this is completely dynamic throughout the program now. So I'm really not sure how OpenTK does that. But at the very least, in Silk.net, you can be very explicit about how you want it to work. Do you only want this first mouse to work? Do you want just any one mouse to work, that you just select from a list. You can do that. You can make sure that all mouses work at the same time. You can make sure that maybe all mouses can move the cursor, but only one mouse can actually click. You know, there is so much freedom here that OpenTK doesn't have. And even though most of that freedom doesn't really make sense, I mean, why would you want to move around the cursor with all of your mouses at the same time, but only click with one of them? Does it make sense? Maybe not. But you have the freedom to do it. And that is, that's what counts, honestly. That's what I think is very, very cool. We can set up all of this connection change stuff. I'm not going to do that. That's going to waste my time, honestly. Of course, I'd have to set up all of the click and mouse move events and all of that. I'd have to set it up for keyboards and stuff as well. It's going to take a lot of time. And honestly, I'm not going to be plugging in and out my mouse in this recording. So let's disregard that for now, but then you know that it is there. And it is quite nice. So what we can actually do is we can just go over all of the mouses, right? Mice, which returns an I read only list of mouses. So you can do a for each loop here. Yes, thank you for that auto fill, but yeah, you know what? It almost did that correctly. mouse in input.mice. So for all of the already connected mouses, I can just set up the click event, you know? I can just set up the click event. And I'll leave this one here. And there we go. So this is just the mouse, but of course I already have mouse here, so it's gonna say mouse 1. That's actually kind of weird. So let's call it right, let's call it a cursor or something. There we go. This is the actual button. I mouse, or like I button, mouse button. That should still work. And then the last one is, oh, it's system.numerics.vector2, right? So the system.numerics.vector2 is that one, right? Which will be the position. Okay, there we go. And now in this function we can do anything. So let's do console.writeLine. And let's say I clicked, for example. There we go. And because we just iterate over every single mouse that is already connected, this will be set up for every single mouse, including the one that I'm using. Honestly, I don't have anything other than this. So let's run this. I think it will keep running. I don't think it will do anything weird if we run it. We get a little window, so there you go. And whenever I click on this window, you get an I clicked. Honestly, it's a little bit delayed, but that's probably because I didn't set any frame rate things. There we go. But we're getting the I clicks, that's great. Yeah, so honestly, this is a functioning program. You get your window, it has the right size, it receives the I clicked events. You're done. Well, kind of. Of course, you do probably want to see something like a triangle or something at the very least. So let's actually go ahead and do that. And if we want to do that, we actually need an instance of OpenGL. So let's create one here. Private static. Call it GL. GL. And then GL. So there we go. And we can also get that from the window, I'm pretty sure. So window dot and then GL context create OpenGL. That's the one. Right, so it's the same thing as create inputs, create OpenGL, and we can set GL equal to this. There we go, much better. You'll notice that if you are familiar with OpenTK, this is very weird. In OpenTK, GL is just a static class. You can call it from anywhere, at any time, in any place, you know, all of that. It's really, really useful. However, it leaves you vulnerable to calling OpenGL when OpenGL is not yet initialized. And that will cause you a lot of issues. If you accidentally do that, it can cause some headaches, basically. What this makes sure is now you have an instance, well, you have an instance of OpenGL that you first need to create. And you can only create this instance after the window is already run and so OpenGL is already initialized. So anytime that you use anything from this OpenGL instance, it will actually be initialized and you can actually use it without causing any errors. So it is a bit of a like a failsafe, basically. It's quite useful in that way, and it also fits better in the whole C# context, you know. In C#, it is object-oriented, so it makes sense to use some object-oriented programming when you're using C#. And OpenTK has a lot of just static classes that are really not very object-oriented, right? Static classes. Although, I mean, I'm one to talk, right? I'm one to talk, but anyways. Anyhow. This is how we create GL. And then, of course, from GL, as you would expect, you can just call all of the functions that you are familiar with. Of course, OpenGL is just a C library, and it's exactly the same for OpenTK and for Silk.net. So the function names are going to be practically the same. What the functions do is going to be exactly the same. How you call them is also almost exactly the same. You'll notice that Silk.net makes heavy use of spans, which is kind of nice, and also refs. But you can still use raw pointers if you really want to. But yeah, maybe just stick to read-only spans for as long as you can. Alright, anyway. Let's see here. Where are we? What are we going to do? Let's just create some VAOs, huh? Probably what we want to do. So we need to go on render. Keep in mind, if using multi-threading, the on-window update method is going to get called from a different thread than the one that created OpenGL. And if you don't know, if you do anything with OpenGL, you can only use OpenGL on the thread that created OpenGL. Therefore, if you're using multi-threading and you're calling this on-window update function with the other thread, which is some new thread, then you cannot use any OpenGL in here. So no OpenGL here, please. And then yes, OpenGL there, please. So on the render will always be called with the right thread. Just to make sure, because yes, that can also cause a lot of headaches. Just in case you're using multi-threading. If you're starting out, probably don't use multi-threading. It's something to get into later. So we can do GL and then set clear color. Clear color, we can just set it to like red, right? There we go. So red, green, blue, alpha. So now the clear color. Oh, that's an update. I'm very sorry. I am a huge hypocrite. There we go. We're setting it to red, so every frame. I guess we better do that just in the onload, huh? There we go. We only have to do that once, of course. And then every time that we clear the screen, it should be red. I don't think we ever clear the screen though, so let's call that GL clear. Clear. And then clear color mask, got color buffer bit. I don't know how that just instantly put down the thing that I wanted, but yes. So we need to clear the color buffer bit, so just all of the colors on the screen. And then it should set it all to red, and there we go. Well, let's be kind of bad at programming and let's create a new VAO on every single iteration. If you want to be a clean, good boy programmer, then you should probably create your vertex attribute array or vertex attribute objects right here in the all node, so you create it only once and then you can render the triangle again and again and again. Instead, we're going to create a triangle in the render and then delete it at the end of render and then create a new one at the beginning and delete it again and create, delete, create, delete 60 times per second, which is really wasteful, but it's just quick and dirty, you know? Quick and dirty. Just to show how open Silk.net works. Yeah, so creating a VAO is very similar to what we would do in OpenTK, right? So we just have some uint VAO equals GL dot and then gen vertex attribute objects gen VAO maybe it's create VAO. It's always different. Yeah, it's just gen vertex array. There we go. Just creates one for you, and it is a uint, not an integer. Sometimes it changes. It's a bit confusing, even in raw OpenGL. Some objects are integers, some are unsigned integers. It's the same thing, really. Okay, there we go. Then we can bind it, of course, just in the same way. Bind vertex array. There we go. Then we can also generate our buffers. So uint vertices equals gl.gen, small l, .gen buffer. Can do the same thing for, do we need the same thing for colors? We can't really use colors, can we? Let's try it anyway. Colors, and then we need one for indices. There we go, gl.gen, keep doing the wrong capitalization, gen buffer. There we go. Then let's set the vertices first. So gl.bind buffer. We have a buffer target. That's an extension. Let's just use a GL enum. Dot and then an array buffer. And then the buffer, of course, is vertices. There we go. I'm thinking that we probably need to get some shaders in a second too, but we'll worry about that later. I kind of forgot about shaders there for a second. We'll do this first though. All right. Let's see. So we can set gl.buffer data. There we go. Of course, this is an array buffer. We just set that. Then we have, let's see, we can use a read-only span with data and then the usage. Okay, let's do that. So we can create some sort of array here with all our vertices in it. So let's create a float array of vertex array equals new float array of vertex array. Of course, in here we want a triangle in 3 dimensions, so that means 9 values. Yes, so let's make our first vertex at position x equals -1/2, y equals -1/2, and z equals 0. Then the second vertex at x equals +1/2, y equals -1/2, and z equals 0. And then the last vertex at x equals 0, y equals +1/2, and z equals 0. Right, so we get a triangle that looks like this. Very nice and simple. While we're at it, we might as well create a color buffer as well. So a color array, we'll use some colors. Let's make it nice and spicy. It's always fun. Let's go. So we need R, G, B, and A for every vertex. We have 3 vertices, so that means 12 values in total. Let's see. Let's make our first vertex red. So that is red, green, blue, alpha. Then let's make the next one blue. So red, green, blue, alpha. And then of course green. So red, green, blue, alpha. There we go. And then lastly, the index array, which is actually going to be an unsigned integer array of index array. And of course, an index array, for if you didn't know, will give us the order in which we draw our vertices. In this case, we just want to draw the one at index 0, so the first one first, then the second one, then the third one. I mean, yes, you're not gonna get any simpler than a triangle. So there you go. That's the whole thing. Anyhow, what we can then do is we can just pass a vertex array in here, just an as span version of it, but then that's a normal span. You cast it to an I read-only span. If I can find it, it's just a normal read-only span. Yes, a read-only span of floats. There you go. And then we need a usage, which will be GL enum dot, and then the usage will just be static draw. I think that's the simplest one to use. If you're confused on anything OpenGL related, OpenGL docs and specs are very easy to find. I'll actually have a link in the description. And yeah, you can find anything you want there, whatever static draw does. Actually, in OpenTK, you always have these special enums. You don't have one general GL enum, but you have like buffer usage dot and then static draw, for example. For here in Circle.net, you just use GL enum, and then you have all of the enums available in OpenGL, which is a lot more than just a few. So it's not different from normal raw OpenGL in C or C++, but it's a bit more work looking through all the options. I'll admit it. OpenTK actually has a leg up here, the upper hand with specialized enums. I hate file I/O in C. Yes, Jimmy, that is very much a thing in C. It's really annoying. You are completely right. Yeah, that is one thing that C# definitely does better. By a lot. By a lot. But I'm sure there are like libraries for that, right? I'm sure there are. Let's see, what are these guys doing? They are enabling the vertex attributes pointer, so let's do that as well. So GL dot and then vertex attrib pointer. There we go, and not vertex pointer attribute. It's always a bit confusing. Index 0, then we have 3 floats, right? So GL enum.float. That's not capitalized. Normalized false, stride 0, pointer null. Yes, there we go. This makes it unsafe. C# has the ability to interpret null as an actual null pointer. However, that is unsafe, so we do need to specify this as an static unsafe. It doesn't like that, why not? Don't use unsafe constructs in safe contexts. Do I need to, yes, allow unsafe, please? And now it does actually need to be on the other side, otherwise Strider will, or writer will complain. There we go. So see, now it works. It just interprets this as a void pointer, so it's basically just int pointer dot 0 dot as pointer. What is it? Pointer. Oh, 0 dot to pointer. It's the same thing, right? And both are unsafe, so it just returns a void pointer. I think it even just compiles to the same thing. Anyhow, maybe not too relevant. And then we need to enable this, of course, as well. Enable vertex attributes. Array attribute or attribute array. Which one was it? Attribute array. There we go. Always confused. It has a enable vertex array attribute and an enable vertex attribute array. I mean, really? OpenGL, why? Anyhow, what this does, let's actually go over it. So we bind our buffer. Then we set the data of our buffer. So of course we just put our vertex points in there. Then we enable the point in the shader that needs to accept this data. So that will be at index 0. Of course, it will be 3 floats per vertex. It will not be normalized, right? I mean, our points can be anywhere in space. They don't need to be somewhere in like a radius equals 1 range, right? Stride 0, so we don't skip anything. It's one contiguous buffer. And then we don't actually have a pointer here. Right, that might be to just set the data from an array or from a buffer directly. But we're going to use a VAO, so let's not worry about that too much. But let's enable that. That's great. Then we need to do the same thing for the colors. Right, colors. Then we need something that is color array. Static draw, it's still the same thing. I have a whole video on all of these buffers, by the way. Go click it. I'll have it somewhere here. So if you want an in-depth explanation of all of these buffers, there you go. Vertex attribute pointer is just 1, 1. Right, because we used index 0 for vertices, so let's use index 1 for the colors. We can't use the same index, otherwise we're going to overwrite things. We have 4 floats per vertex here, right? We have an R, G, B, and A. And lastly, we're going to need our indices. Note that this is not an array buffer. This is an elements array buffer. Element array buffer, kind of the same thing with an index array here. Only, right, this should be a unit. Only, index array isn't actually an array that the shader receives directly, so we don't need to enable any attachment points within the shader. The element array buffer will be used by the draw call directly. Right? It will tell the draw call how to draw the data. And the data itself gets forwarded to the shaders. Okay. Now let's see. Now we can actually call something like GL dot and then draw elements. There we go. We'll have GL edem dot triangles, right? So we're going to draw triangles. Then count, we'll have one triangle. Type. Right. The type is actually the type of elements that you're using, or the type of indices, which in our case is an unsigned integer. Right? We're using unsigned integers for our indices. And then the last one has to be null. So you can pass in, allegedly, you can pass in the indices, a pointer to all of your indices directly into the draw call. But for some reason, that just never works for me. I don't know why, it never works for me. Instead, I still have this index array bound here. Therefore, it's still bound, so it's used. If this is null, it just uses whatever elements array buffer is bound at that point, which is our index array. So that works out for us. I'm not sure why doing it directly through this call doesn't work, but oh well. That's probably a me issue. Should probably unbind the color array here. So let's unbind that. Just set GL array buffer to 0. That means that you unbind the array buffer. There you go. Then we can draw the elements. And after that, we can also unbind the index buffer. So let's do that. Then we can also unbind bind array, vertex array, VAO. Unbind that, and then we can start deleting things again. So GL and then delete buffer vertices. We can delete buffer colors. There you go. And you can delete buffer indices. Make sure that these buffers are unbound when you delete them. Otherwise, OpenGL will wait with deleting them until you actually unbound them. It's not that much of an issue because you will inevitably unbind these in the next call, right? Because you bind these new vertex array and color array and index array. But be aware of that. GL.delete vertex array VO. And I think we have everything then. Of course, this will not work because we don't have a shader. I'm actually interested just to see what will happen if we run this. Without a shader? Yeah, nothing. That makes sense. Let's get a shader, huh? Let's get a shader going. Actually, I'm going to copy whatever shader they have here in the documentation, because honestly, I can't be bothered to create the whole thing myself. Let's see here. So they have a fragment shader and a vertex shader. Let's copy and paste that. We'll make some tweaks ourselves. Usually I create a file and then work from that file, but this is just for demonstration purposes, right? So this comes straight from the documentation. Of course, documentation will be in the description as well, so don't you worry about that. So let's see here. So same thing, vertices, we take them in at location equals 0, right? We have 3 vertices, so effect 3 per vertex position. We also have a color, actually, right? At location 1, remember that. That is effect 4, because we have an RGBMA. Let's call it vCol. Then we need to output the color as well. So let's have an out vec4 and then call it outCol. We need to set the outCol to our input color. Because of course in a vertex shader you can't really do anything with colors. If you're interested in OpenGL shaders, then I have another video. Maybe it's like up at the top somewhere, otherwise it's in the description. Where I go into more detail, of course, on all of this. So this is, the rest is exactly what you want, right? Set GL position to X, Y, Z, and 1. Totally correct. Then in the fragment shader, we actually need to have in, vec4, and then, right, I'll call it out call. Needs to have the same name as it has in the vertex shader. So yes, let's call it out call. It's a bit unfortunate, but it's fine. You can name it whatever you want. And then here we will set the frag call just simply to out call, and that will just copy, and then it should work. Right, in loading here, I want to actually load the shader. That does mean that I need to store it somewhere, so let's have a static uint, let's call it program for shader program. Right, so in all node we can start loading our program, so we can do gl dot and then create shader. Here, so that does actually have a specialized enum here for shader type. No, why does it do that? Shader type, why? Go back, right. Shader type dot vertex shader. So we can use this, and it will just create a uint v shader. Let's call it that. Of course, you can also just use the general GL enum. So we can use GL enum here as well. And that will all, this does the exact same thing. You can see that this is equal to 35,633 and the vertex shader is equal to 35,633. These are the exact same numbers, and so they will do the exact same thing. It is nice though to have it in a specialized enum, because then you can very quickly just browse through your options. Like these are all of the options that you have. Nothing more, nothing less. While in GL enum, you have many more options than you actually have, and it's very difficult to just browse through it and easily see what you can actually use. So we'll use shader type here, it's a lot better. Anyway, we'll also create a fragment shader. Fragment shader. There we go. Then what we can do is gl.set shader. No, shader source. Yes. We can set it from v shader. We can set the shader source to just a string. Which for us is that one. We can do the same thing for the fragment shader. For now, I'm not going to do any error checking because I'm lazy. I think we then need to compile gl.compile shader. Yeah, right, v shader. And then the same thing here, gl.compile shader f shader. Okay, good stuff. Then we can attach it to an actual program. So we have program equals gl.create shader program. Right. Let's create your program, then we can attach everything. So gl.attach shader to our program. And then the shader, of course, is v shader. Same thing here, but then for the fragment shader, so program shader. Not sure if we need to attach our program first. No, that's fine. Okay, gl.link program. Right, and then we can detach the shaders again. Detach both. And then actually we can just delete the programs, or delete the shaders. Delete shader. There we go. V shader. Again, do this after detaching, because otherwise OpenGL will just wait until you detach it. Right, because OpenGL detects that you're still using v shader, and therefore it will not delete it. It will wait with deleting it. But you never detach it later in the program, so it will actually always remain in memory. So detach first. Right. And then let's just use gl.use program. Actually, let's use it later. Okay, so we have this. That should just be fine. And then before the draw elements call, we'll use GL, the use program of our program. All right, so we'll make sure to use it. Okay, let's run it. Let's see if that actually works. We have any issues? Oh, we definitely have some issues. It doesn't crash, however. But it seems very likely that we probably made a mistake somewhere in the shaders. I mean, that literally happens every time. Anyway, let's copy the debugging code because I don't feel like writing it myself. Can get program, can get the link status, and otherwise can print the info log. So if we have an error in the linking of our program, then we print an error, right? Let's run it. There we go. Layout location requires extension. Requires extension. I mean, I can look at my own shader. Oh wait, I'm using 2 times vertex shader. Maybe that's it. Yeah, you know, that could do it. Let's try that again. Yeah, make sure your fragment shader is actually fragment shader. Yeah, now it doesn't crash. That makes sense. It doesn't draw anything either, though. Like every time, literally, it doesn't matter how often I do this. This is like the bajillionth time I do this. And every single time, there's always something that I miss. There's always some little issue that I miss. Length unsigned int. You think length has to be 3? Right, it's not 1 triangle, it's 3 vertices that we're drawing. Yeah, okay, that's my bad. So we're drawing 3 vertices and not 1 triangle. Okay, simple enough. My bad. I'm very sorry. And there we go. With a red corner, we have a blue vertex and we have a green vertex. It could use some anti-aliasing. That looks pretty bad here, but oh well for for demonstration purposes. This works. So we now have a very basic Silk.net application. I mean, we can resize it and it won't really be that pretty, but again, we can change that basically whenever we want. It's been half of just an OpenGL tutorial, honestly, at this point. I mean, that's always the case with these types of things. That was also true for the OpenTK lecture. This is just to demonstrate, of course, how to use Silk.net. You can see it is honestly very similar, right, to OpenTK with a few notable exceptions. So the notable exceptions are that you have a separate input context. In OpenTK, it's all the same, right? The input is inside of the window, and you can use them. Well, yeah, you can just use it at any point, even when the window is not initialized yet. Same thing with GL. GL is always available as some sort of static class. You can use it whenever OpenGL isn't even created yet. That can be a bit of a problem sometimes if you're not really paying too much attention to it. Then, well, you might get some really weird errors, and then it is very hard to find out what exactly went wrong. Right, and then what else is super different? I guess you have different numerics types here. Also, Silk.net uses the actual system.numerics. Like right here, it uses the system.numerics instead of its own numerics types. I'm not really sure why they do that. Honestly, they should use system.numerics everywhere, because system.numerics is great. But then again, system.numerics has its shortcomings, I guess. Right, so having an integer vector in system.numerics is a bit more difficult now that I think about it. So that's probably why they have their own. Fair enough, you know, never mind. I said nothing. I said nothing. and honestly, anything else is basically just the same. Right, you're using the read-only spans instead of just a raw array. In OpenTK, you just put vertex array here. In Silk, you put vertex array.asSpan. The only annoying thing is, the only thing that I could remark upon here is that asSpan returns just a normal span, and so you still have to cast it to a read-only span. It's just kind of annoying, but for the rest, you know, it's fine. It's fine. And oh yeah, of course, the enums, you don't have like special enum types like an OpenTK. I guess they're working on it then. Like I said, it's still a very young project. It's a lot younger than OpenTK, so there are probably going to be more errors, more problems, more of these incomplete type of things, right? So shader type .vertex shader is a lot more just user-friendly, a lot easier to use than GL enum everywhere. But for now, you know, this is no different from C or C++ GL. In C, C++ GL, you just have to write array buffer like this directly, or well, it's actually GL array buffer, right? And there's no help. If you don't have an IDE, there is no help. If you do have an IDE, then after you do GL underscore, you get like a couple options. Yeah, and with a couple options, I mean literally everything that's in GL enum plus more probably, because OpenGL has some legacy stuff that is probably not in GL enum right now. Anyway. Yeah, I think that is the most important part. I do want to show ImGui, because of course ImGui is why I went to Silk.net. That's why I abandoned OpenTK. Well, I didn't abandon it, of course. I still like OpenTK. It has its advantages, right? If you were to start a new project now, though, I think going with Silk.net is a very viable option. Maybe even a little bit better than going with OpenTK. But of course, it's always up to you. And always up to your use case. If you are still learning OpenGL, like really learning OpenGL, and you like the extra like guidance that these named enums give you. So let's say here, right, in create shader, if you are learning OpenGL and you really don't know what is accepted by this function, then it's really nice to have these named enums where you can just check out the type, right, and you know that any of these values will work, and that's it. So you don't have to look for too long. You can actually quite quickly determine, well, A or B is usually not what you want. Test evaluation shader, what the hell is that even? Vertex shader, that's probably what we need, right? And you can probably find something cool with compute shader as well. It's a little bit easier, and therefore I would recommend still OpenTK if you're still beginning. Otherwise, Silk.net is just great. Right, so if we want to do ImGui, we can create an ImGui controller here at the top, which is basically going to be similar to the input context and all of that. So private static ImGui controller, and maybe I need to import something here. Controller called ImGui. Let's see, can I just import it? No, I can't. Okay, well, let's see if we can find it. Silk.net, I don't even know what that did. Something just happened. Let's OpenGL.extensions. Oh, we just don't have it. Okay, so we need to go to NuGet, and then there should be a ImGui extension somewhere. Let's see. Here. The OpenGL extension.imgui, that's the one that we want. We need to install that one as well. Right, let's go. And there we go. Ah, look, now it can find it. So it's imports. There we go. Yes, so that doesn't come with the basic package of Silk.net, but you can just download the extension separately. So it's actually just quite fine. It's fine. Anyway. Let's see, where do we get this? So in onload, yes, so we can create ImGui window dots, and then we have something like, can we create it from here? Maybe not, maybe it's not that simple. No, we just need to create a new ImGui controller. It's not that simple, unfortunately. All right, so we need our GL. That is totally fine. We need our view, which is just a window. Then the input, which is just inputs. Right, there we go. Simple enough. Now we have ImGui, or at least we have a handle to it. So now we can probably use it. So let's see here. Render, update, and dispose. We probably need to call those ourselves, don't we? We definitely do. So let's see here. So in the update, we should probably call ImGui.update, right? I don't know why delta seconds is in floats here, while in the window update it's in doubles. That is honestly very weird. That screams that someone else worked on this code. Like, these are two different people working on this code. All right, that's a little thing, I guess, to change in the future. And then at the end of our render function, we should probably render ImGui as well. There we go. Right, yeah, that's great. Oh, in the documentation they just have like some function show demo window, which isn't even here. Right, that's great. Is this something that I can access here as well? The ImGui net? It is actually. Wow. ImGui dot and then show demo window. Oh, right. So it is actually something that we have as well. Well, we can do that. Let's see what it does. Ah, there we go. We have a demo window. That is crazy. ImGui, hello. So, okay, this is not an ImGui tutorial anyway, but just how to set it up in Silk, which is really easy, as you saw. Right, so we have a help. That's actually quite nice. Configuration window. It's a little bit small, honestly, but I don't think I can make it much bigger. No, it really doesn't like that. It really doesn't like that. Let's rerun this. Rerun. Okay. We're not properly closing this, by the way. Maybe I should real quickly do that. Filtering, yeah. Okay, very interesting. Anyway, this is ImGui, just working. So really the only thing you have to do is just create it, right? ImGui controller, and then just update and render, and then just before rendering you can do whatever you want. So ImGui net.imgui, you can probably import this, right? Then you can begin something, or you can just create a button, right? So let's do a button. Let's call it hello. And then the size is... we're just going to use default size. Is that just going to show up just like that? Yep, it's just going to show up just like that. And now we have a hello button. That does nothing, but it's kind of nice to just have. I'm going to make sure that this code is uploaded on GitHub before this is uploaded on YouTube. So there is a link in the description for you all to view this code. I will also link the ImGui GitHub as well, on which there are even more tutorials and documentation than just this. I'll also link ImGui and the OpenGL specs and a bunch of videos where I dive deeper into like shaders and buffers, all of that, for if you're interested in learning more. For now, I think this is going to be it. If you want to see this live, go to Twitch. Twitch.tv/anotherman, also linked in the description. If you want any help, if you are stuck on anything, go to the Discord. Link also in the description. Go there, we love to help you out there. We have a wonderful community, so do check us out. Yes, any questions from chat? I think this is gonna be it. Anything that y'all would like to see still?